My name is Chris Feltz. I work on our product team at OSIsoft. I work for Greg LeBlanc, who you saw this morning present with Chris Nelson. So today we're going to talk about pervasive data collection. I hope you understand that. And like maybe the pilot says, if you're not on your way to Gothenburg, this is the wrong airplane. So if you're not here to learn about pervasive data collection, you're in the wrong airplane. So we're going to get into it, I think. Okay, so you saw this slide this morning. This started as a representation of our development initiatives that we started a couple of years ago. This is kind of morphed into explaining what we're doing at OSIsoft. Pi system, edge, and cloud. So we talk about extending your data infrastructure from the edge to the cloud. So really today what we're talking about is what are we doing at the edge, but we're going to tell you a lot about products and technologies that we're building, but really the data collection spans across all of these. We want data collection for the edge. We want that data collection to go into Pi servers. We want that same data collection to go into OSIsoft cloud services. And I'll try and use the formal names for these things, but you might hear me slip and use the acronym OCS or EDS. Okay, so pervasive data collection. If you've been here, we talked about this last year. Pervasive data collection, as we look at what we need to do at OSIsoft, I feel we have an obligation to you, our customers, to provide data collection and to store that data and to serve that data up to your applications. That's been our hallmark with the Pi server. We want to continue that as we extend this data infrastructure to the edge and cloud. So pervasive data collection is really a collection of products and technologies to help extend that data collection to the edge. It starts with our traditional Pi interfaces and connectors, extends that now into the Edge Datastore that we'll talk about, or EDS, our open source strategy that you heard a little bit about this morning with our partner Dynamic Systems, and then OSIsoft message format kind of wraps that all up. So why are there four things? Well, because we expect there'll be quite a wide variety of not only amounts of data that you have to collect, but also the hardware platforms that you want to run this data collection on. So as you think about our traditional Pi interfaces going way back, they today run on Windows PCs. They typically run in your plant, collect data from your large automation systems and other historians in your plant, where you're talking maybe hundreds or thousands or tens of thousands of events a second through these big automation systems or these other big historians. That requires a high compute resources. You think about the requirements Microsoft puts on a Windows PC, lots of software, including our own, can run on that, but that's a pretty high bar, right? You need a certain amount of CPU, a certain amount of memory just to run the Windows operating system. But we expect when these IoT scenarios, a lot of the cases we hear are, I have these new sensors that we're putting in the field. Like think about the excellent presentation that Sandvik gave. I love that. That was such an awesome presentation. But he talks about putting these sensors on their assets, their machines, and he made a point that he did that himself. The manufacturer didn't provide those sensors. So you think about cases where I just have a sensor giving me maybe one or two pieces of data a day. I don't need a Windows PC for that. So we want to extend our data collection to go all the way down to the individual sensor. So there's quite a wide variety then of throughputs, stream counts, as well as hardware resources. So that's how we differentiate these four things, because they're meant to do certain things. Pi interfaces and connectors are really meant to run on Windows PCs in the plant and collect that high volume data. And then at the other edge of that spectrum, we have something like OMF that can be any hardware platform and any operating system it can run on. And then in between, we have our Edge Datastore, which we'll talk about quite a bit in this presentation, as well as our open source solution with Dynamic Systems. One other dimension to this development, and this is what Greg showed this morning, this vertical bar here, there's also a distinction or a dimension of development effort. So when I talk about a product, that's something that OSIsoft brings to market. An interface or a connector is a product. Your experience with that product is you buy it, you download it, you install it, you configure it, and then the magic happens, right? The data starts to flow. Compare that with a development effort like OMF, where we give you a message specification that says, if you adhere to this message specification, you can build an application and we'll love that data as if it were generated by our own software. But your development experience there is much different, or your usability experience, because you are developing that application or somebody's developing that application for you. We're just giving you the means to easily get that data into the Pi system and into OSIsoft cloud services. So there's also quite a range in development effort as well, and that's why we we have these four things. Some people want the experience that, no, I want to own that data collection and I want to make it easy to get that data into Pi. Some want, no, my experience, I want to download, configure, and use. So that's why there's several things. Okay, so we talked about, you heard it today, extending the data infrastructure. So another dimension of why there are four things is we now have three systems to target for this data. We have our traditional Pi server that's going to continue to evolve and serve these on-premise, if you will, data collection and data storage needs. Now extended to the cloud with OSIsoft Cloud Services and extended to the edge with, again, the Edge Datastore. So when we look at interfaces and connectors, we made a decision to say we're going to continue to focus that development on our traditional Pi system. So the interfaces and connectors we build today and will continue to build and enhance in the future, we'll target Pi as their destination. So we'll talk just a couple minutes about that. So Pi interfaces, hopefully most folks here know what a Pi interface is. It's our traditional data collection technology going back 3 decades, back to the origins of Pi version 1, where we ran on things like a DEC Alpha. 30 plus years of developing these things, and over the years there's now north of 400 Pi interfaces that we built for lots of different things. So very mature technology. It represents a majority still. Today our most popular selling data collection technologies are Pi interfaces. So I just noted a couple of things. We're building new Pi interfaces, even though it's legacy technology, there's still a need to build them. So here's 2 examples of 2 interfaces that we built this year, 2019, or are building. So just an excerpt, we spent a lot of time this year building out and enhancing interfaces and connectors, so I just grabbed a couple of highlights. You saw very briefly this morning in the Pi for Critical Operations context that Chris and Greg presented. I think they called it interface health messages. So one of the things we've added in conjunction with our what we call Pi for Critical Operations is the ability for our most popular interfaces to provide health messages, and they generate OMF data so that health data can be consumed by a Pi server or by OSIsoft Cloud Services or even by an Edge Datastore. And here's a list of our 7 most popular interfaces that have that is enhanced. Interfaces have their own diagnostic data, but we've enhanced that by these couple of OMF health messages. In addition to that, we've done a bunch of work on our batch and MES interfaces, and here's an example of 3 of the things that we've done, as well as all new batch interfaces and MES interfaces we build will be 64-bit. And then a lot more. In the exhibit hall right next door, there's a data collection booth where you can see interfaces, connectors, talk to the development team there if you have specific questions. Okay, so on to Pi connectors. It's our now current most common or most modern data collection technology. It's 6+ years old, so this is the most recent thing we've been working on. To date, we've built, I think there's 21, and then there's some new ones that you'll see. It is, again, our most modern data collection strategy, and you guys probably know about these things. OPC UA is our most common connector that we sell. And again, here's some new ones that we've built and released this year, 2019, MQTT Sparkplug, MT Connect, and OBIX. And there's some new ones in development, so 3 new ones that are in the works. And then I picked out the OPC UA and Signet as 2 of our most common connectors that we've done some enhancements to this year. So just again, a suggestion that we're continuing to build interfaces, enhance interfaces, build connectors, and enhance them, again, to protect that investment that you, our customers, have made in this your Pi servers. And again, a couple of highlights. MQTT Sparkplug. MQTT has been a very popular protocol for IoT. It's a kind of fire and forget message queuing protocol. So we have a connector that we built and released this year that communicates over the MQTT Sparkplug B. So again, very popular. It's kind of hits lots of different industries. As well as OPC UA, I mentioned that's our most common connector. We've done some enhancements to OPC UA, including tag naming and mapping. One of the things that we've heard feedback for you is, as we built connectors, we thought it was smart of us to take that development effort away from you of defining your tags up front, doing that Pi server back-end work, and then having your Pi interfaces align with the Pi tags you built. Connectors automatically build those tags. We thought that we were doing you all a favor by taking that effort away from you. But what we've heard over the years, the 6+ years, is we have our own tag naming convention. We really want connectors to adhere to our own in-plant or corporate-wide naming convention. So we've given you the ability with connectors to define what how those tags get built by Pi connectors. And we have that demonstrated with our OPC UA connector. And again, we picked that as our most common one to demo. So again, stop by the booth, check that out. You saw, again, a little bit this morning, our new roadmap. So we have a new strategy and style of presenting how we're building all the products at OSIsoft. So this is what the new roadmap format looks like. You didn't get to hear too much about it this morning, so I'll, since I'm the first product talk, explain a little bit. So developing now means that's the new products or the enhancements that are in active development. You know, as we're sitting here today, the guys in California are going to wake up and they're going to start coding, and that's what they're working on, is in the developing now column. Considering next means we have plans, approval to start development on these features. We just haven't started them yet, but we know these are pretty well given that these are features that are going to come at some point in the future. And then researching future means these are things that we kind of think we need to do. It's the most squishy of all the things on this list, but it's kind of gives you an idea of where we're headed with the products. So you'll see a roadmap like this for all the product talks you see this afternoon, as well as we'll see another one today. So I won't go and read them all, but you can see here by reading the slides, here's the things that we're planning. So one of the things you see in the considering next is enhancements we're planning to make to our real-time connectivity, so you can use your imagination and see what that might mean from a connectivity standpoint. Okay, so one of the things I talked about, three new back-end systems, I say, to get data in. So Pi connectors and interfaces, again, will be targeted at Pi. That will be their destination, no other things to send that data to. But now to get data into our cloud system and into our edge system, we're now focused on these next three things. So our edge data store, our open source work with the dynamic systems and OMF. So we'll talk real briefly about OMF and dynamic systems open source work, and then a lot on edge data store. So how do we do this? How do we get these three things to be able to send data to all three systems? Well, that's really OMF. We've talked about OMF the last couple of Pi Worlds. So what OMF is and really it's an abstraction layer. If you think about the Pi server, it has an application interface. There's an AF SDK if you want to do .NET programming. There's a web API if you want to do off Windows, RESTful-based programming. As we built OSIsoft Cloud Services, going back 5 years, we thought, how do we make it easy to get data into OSIsoft Cloud Services? And as you heard a little bit this morning, the consumption, the way that OSI Cloud Services is brought to market is a consumption model. Put in as much data as you want, and then the meter runs as you consume that data. So we wanted to make it easy to get data into OSIsoft Cloud Services. So OSIsoft Cloud Services has a very rich API that you can program against, but then also we built what we call OSIsoft message format. So instead of saying, you, the developer, need to learn how this API works and how the back end works, we said, no, if you just send your data to us in this message structure, as I said already, we'll consume it as if it was generated by our own software. So it's really a way to easily get data in to OSIsoft Cloud Services. All you have to do is adhere to this contract, this message specification, and we don't care how that application's built, what operating system it runs on, what tools you use to build it, what it does. All we really care about is when you send that data to us, that data conforms to this paper specification. The specification's public. It's up on Read the Docs. Here's the example of the home page, and here's the URL for the specification. So again, just for clarity, this is someone else is building this application. OSIsoft provides that endpoint to send the data to. That's it. We're not providing you anything for OMF. It's an application development effort, just for clarity. So that's how that works. So 2 years ago, the Pi World San Francisco 2017, we announced OMF into Pi. So as we looked at OMF into OSIsoft Cloud Services, we thought, well, that's a pretty good idea. I bet Pi developers, folks that are working with the AF SDK or the Web API, might like an easier way to build those applications. Why don't we extend that endpoint to the Pi server? So we did that. And at the time, we thought the best home for that OMF endpoint for the Pi system was the Pi connector relay. And so OMF 1.0, the first generation of OMF with the Pi server, was implemented via the Pi connector relay. So if those of you that use connectors understand that some connectors that we built have this software component called the Pi connector relay. I'm not getting into that, but just believe me, that's a component of these connectors. But then as Chris Nelson said this morning, we thought, OSIsoft Cloud Services is built natively with this OMF endpoint. With Pi, it's something that we've added after the fact. So then we kind of rethought, how might we make OMF more of a first-class citizen with the Pi server? Let's implement it closer to the Pi server and then have it built and delivered as part of a Pi system deliverable instead of as a connector deliverable. So that's why then over the last year or so, we've migrated that endpoint from the Pi connector relay to the Pi Web API. So those of you that aren't using OMF, maybe this doesn't matter too much to you, but those of you that have, it's been fairly popular and adopted quite well in the last couple of years. This is a change you'll see coming out. So behaviors, very similar. It's just now with the Web API, that's at OMF version 1.1. And then all future revisions of OMF, the implementation on Pi will be through the Pi Web API. And as Chris mentioned, it's part of the deliverable with Pi Server 2018 SP3. I just learned this morning, Chris called it Pi Web API 2019. So I would have added that here, but I didn't know that until this morning. And then at the Developer Technologies booth next door, you can see that in action, Web API with the new OMF endpoint, as well as in our Edge Technologies booth. We have OMF applications running as well as Edge Datastore. So you can talk to the Edge Technology guys as well. Okay, now the rest of this time we're going to spend, we have 22 minutes left with questions on Edge Datastore. So it's the thing that we've been working on for a couple of years. One of the questions I get quite common is, what is this thing? Is it just a small Pi server? Is it a derivative of Pi? I hear people call it Pi Lite, Skinny Pi, Pi Core. It's none of those things. Edge Datastore is a brand new development. We looked at the market a couple of years ago and where we needed to go with data collection, and we saw lots of scenarios where Pi server, it needed data collection, it needed data storage outside the walls of the plant. In a lot of these cases, the Pi server wasn't a good fit because one, I can't afford from a cost and development effort or management effort to run a Windows PC. I need something lightweight. I need it to run on Linux. I need it to be in a robust environment. I need it to run where there aren't humans around to care and feed it. And so it was like, well, that's really not a connector or an interface because you need data storage and you need access to that. It's not a Pi server because I need low maintenance and I need a non-Windows operating system. So that prompted us to build now what we call the Edge Datastore. So it's a set of brand new technology built from scratch to address these cases where I need data collection and storage at the edge. I need it to run on lightweight devices, low cost. I might have thousands of these things in the field, so I don't want to spend, a bunch of money on hardware. All of these things combined to be now what we call the Edge Datastore. So it's not a Pi server. It doesn't really share any DNA with Pi, but what it does share is storage technology, and its API is shared with our cloud services. And so the significance of that is, like OMF, I can build an OMF application for ingress into an Edge Datastore, or into Pi, or into OCS. Well, now as I think about application development on top, I have an application that I can build against OCS, use its API, and then the Edge Datastore's API is a subset of the OSIsoft Cloud Services API. So it shares DNA with OCS. Even though it's not Pi, it's complementary. You heard Greg talk this morning about Pi as our system of record. OSIsoft Cloud Services in the future may be your system of record. Edge Datastore, although it does persist data, we expect it to be a temporal storage. We expect it to run on small devices where there's not a lot of storage available, and eventually that data will need to go into your system of record, your Pi servers or your cloud services. So we did build into an Edge Datastore the ability for it to know how to send its data to Pi or how to send its data to OSIsoft Cloud Services. That's an expectation that we put on the Edge Data Store, that it's not persisting data forever. It eventually uploads its data, or if not, it acts kind of like a first in, first out buffer. So after some period of time, you're going to run out of storage, and if you haven't uploaded that data to your Pi server, to OCS, it will eventually overwrite that data by design. Okay, so we talked about, why you have interfaces and connectors in the plant, why you have Pi servers in your plant. These are the types of assets we expect Edge Data Store runs on, and this is somewhat representative of the partners that we've had and customers working as early adopters. These exemplify the assets that they run on. With the exception of this lower left-hand corner there, that skid, we do expect the Edge Data Store to be very conducive to an OEM type environment where a partner might want to embed the Edge Data Store on their skid or on their piece of equipment. Like again, in Sandvik's case, maybe that would be an Edge Data Store would run inside their machine, collecting data locally, feeding a local application, persisting that data, and then sending it up to a big Pi server, by example. And then these others are just typical remote assets in the industries we serve. Okay, so what is it? Edge Data Store by name, by its capability, we focused the first release. So what you'll see in the exhibit hall next door represents our first release of Edge Data Store, version 1. Really focused on that core competency of OSIsoft, data collection and storage, the way to get data out and serve it to applications. That's the focus. And think about the evolution of this, like the Pi system today. I get lots of questions about why doesn't Edge Data Store have this function or this feature. Go back 20 years, you had a Pi data archive. And then with that, we supplemented module database, and then that evolved into AF, and then that evolved into asset analytics, and process book evolved into CoreSite, evolved into Vision. So this is the same. We'll be on a development journey with the Edge Data Store like we've been on with the Pi server, like OSIsoft Cloud Services will be on as well. But at our heart, I wanted us to focus on providing the best collection and storage system that we could for the Edge. And so that's what you see represented here. So it's software. It will rely on hardware. So like the Pi server, we want to say with Edge Data Store, here's a criteria for CPU, for RAM, for storage, based on your scenario that you want to apply the Edge Data Store. Commercially, we're going to go to market in a small, medium, and large set of streams. So small is 1 to 50 streams, medium is us 51 to 500, and large is up to 3,000. So we're really targeting those cases where, again, Pi isn't a good fit. I kind of feel that once you get above a few thousand streams, that's probably not a little edge device anymore. That's probably a server. That probably is a Pi server. So that's really our focus. So roughly in the 1,000 streams up to 3,000 streams kind of range for the upper end, and then all the way down to a few data streams. With the Edge Data Store and with OCS, you probably heard streams. We're not calling these things tags because people kind of think tag and they think Pi together. So the pieces of data that you collect in an Edge Data Store, we call those data streams, just for clarity. So what type of devices will this run on? Again, I mentioned small, medium, and large from a stream count, but then also that's representative of the types of hardware we expect the Edge Data Store to run on. And I brought a little prop with me today. So in the upper right-hand corner, this is what's called a pocket beagle. That's this big. That's a US quarter next to it. That's about the size of a euro coin. So this is the type of device. When we say small devices, this Edge Data Store is running on this device. You'll see this same thing in the exhibit hall. So you think about the installation and the maintenance of this versus the installation, maintenance, and cost of a Windows server. And that, again, exemplifies why we have something called the Edge Data Store and not the Pi server. Runs on little devices. And then this is a Raspberry Pi. That's kind of like our medium-sized device. And then you get up to the large devices where you have a reasonable amount of CPU and memory. You get into more of a traditional gateway. So there's examples of the gateways that we're using to run on Edge Data Store. You can see them in the exhibit hall. Okay, interoperability. One of the things I felt was important, or we felt was important, to provide basic connectivity as part of Edge Data Store. So we added in-process connectivity for Modbus Ethernet and OPC UA. Again, our two very common interfaces and connectors that we have today. So Edge Data Store is delivered with OPC UA and Modbus connectivity, as well as the OMF endpoint that we talked about. So that's how you can get data in. It's a configuration exercise to configure your Modbus device or configure your OPC UA server. And then in addition to that, as we've talked about, built-in egress to OSIsoft cloud services or to the Pi server, and it generates OMF data outbound. That's really the focus of what we're doing here. Get data in, store it, serve it up, send it. If you have a little bit bigger device, I played a little bit cutesy with the size of that box. A little bit bigger gateway, maybe I have overhead to run applications, to run an OMF application or to run visualization or analytics. So this is where I have the ability for others to build analytics, to build visualization, to build OMF applications. So if Modbus Ethernet or OPC UA aren't your data sources, you have the ability through OMF to easily develop an application. I say easily in relative terms, to get that into your Edge Data Store, send it up to Pi. Next door at the exhibit hall, we have some partners that are exhibiting Edge Data Store. IPCOS is one of them. They've done exactly this. Although they're using Modbus to get data in their scenario, they built local analytics to process the data in the Edge Data Store, write results back as new streams, and then on the outbound side, you have the feature to selectively choose which data streams you want to send. So a nice way to show data analytics, and they also have a little visualization application. You can see that next door at the IPCOS booth. So for clarity, we expect others to be building the visualization analytics OMF applications. That's something that's not part of the Edge Data Store. But again, the evolution of the data store, we expect over time to increase the amount of data connection options you have on the inbound side, as well as provide analytics, provide visualization from OSIsoft. But in the meantime, you can do that yourselves or do that via your partner. As part of our Edge Data Store documentation, we know specifically analytics and visualization, common things we get asked for. We did provide some examples of how to easily do that. So if you look at our Edge Data Store user guide, you can see how to quickly and easily build a analytics application or a visualization application to work against the Edge Data Store API. So here's the partners that I mentioned. You can see them this week. The ones with the little yellow bar, they're here present at the show. So again, no particular order. IPCOS, they have a booth next door. You can see their analytics application, their visualization application, how they send their data up into Pi, and then visualize those KPIs, their analytics in Pi Vision. Our friends here, Rolos, here in the front row, second row, they have a showcase where they're demonstrating their use of Edge Data Store and their partner showcase talk on Thursday. So go see Martin and his presentation on Thursday to see how they're using Edge Data Store in their scenario. Nextcom is one of our hardware gateway partners. They've been working with us as early adopters of Edge Data Store. We have a Nextcom gateway at the Edge Technologies booth. So it's a little bit bigger than this, but it's kind of like our large gateway. It's about the size of a cigar box. And then Transpera, UET, or a couple other folks that we're working with that gave us approval to use their name. So they're not here, but just a couple others. And then we have several more. Some folks weren't comfortable having us share their name without them being here, so we've got a dozen or so partners on the Edge Data Store. And we'll talk about you becoming a partner as well. So Edge Data Store, it also has a roadmap. So what's in the developing now column, that's what we saw. That's our first release capability. Considering next, those are two things that we're working on after we get the Edge Data Store release. So remote management, and then again, as I mentioned, additional data connectivity options, as well as calculations visualization. That's something that we're considering and we need to be delivering in the future. So you heard Chris Nelson mention Lighthouse Program. So what we're doing with the Edge Data Store, we have a release candidate out. Typical behavior of OSIsoft is, if you've worked with us as early adopters, we have a series of betas perhaps, and then a release candidate, and then general availability. What we're doing with the Edge Data Store a little bit different. We're going to what we call a Lighthouse Program. So we're taking our release software, and instead of just providing it to you as something you can go and use and figure out yourself, we're running everyone through what we call a Lighthouse Program. So what that means is you say, hey, that sounds really good, and I think I have a really great scenario for the Edge Data Store. I'd love to use it. So I'll advance one slide. So what the Lighthouse program is we're going to offer you the Edge Datastore. We're going to offer you people to help you program manage your scenario. We're going to offer you engineering resources to get it installed, get it running, making sure it's doing what it's supposed to be doing. You and I, you our customer, you our partner in OSIsoft, we're going to agree what the scope of what we want to achieve is. So we're going to write a document that says, here's what we want to do together. Here's the milestones that we want to achieve as we work together. And at the end of 6 or 8 weeks, we want to say, were we successful or not? Did we meet our milestones? Did we meet our objectives? So then in turn, what you're going to give us is the willingness to do this, to engage with us in this Lighthouse. You're going to give us a commitment to say, yes, we're committed to working with you to deliver this, to complete this task in 6 to 8 weeks. And then at the end of this, what we'd really love to be able to do is write a success story to show how you, our customer, you, our partner, and OSIsoft, we work together to solve some problem that you had that you couldn't solve today with our traditional Pi servers, Pi interfaces, or Pi connectors. And then what would be extra awesome is I'm standing up here at a stage in San Francisco, and you're standing with me, and we're telling our customers what a great experience we both had. So that's what we want to achieve with the Lighthouse program. So if you're interested, talk to me afterwards, and we'll see if it's a good fit. So join us. So what we have available for you the rest of this week, Product Expo, I mentioned these many times, data collection booth, Edge Technologies booth. We have 2 partner booths, IPCOS that I mentioned using Edge Datastore, and then Dynamic Systems. You can see their open source software called FogLamp at their booth. The talks we have, so the product talks are immediately following mine. Pi for Critical Operations, Mono will talk a little bit about Pi Web API, OMF health messages. Laurent will tell you about our cloud services, so how Edge Datastore and OMF interoperate with OSIsoft cloud services. And then also on Thursday, there's a OSIsoft cloud services for developers. If you're interested in learning how to develop against OCS, that's the class for you or the session for you. We also have an OSIsoft message format lab. We've offered this lab in the US-based Pi World the last couple of Pi Worlds. Been very popular. That lab is happening this week on Thursday. If you haven't signed up, there's probably still time. The Dynamic Systems guys have a similar lab for FogLamp, so how to use that open source strategy that generates OMF data that goes into a Pi server, into OCS, or into EDS. And then as well as I mentioned, Rolos' Edge Datastore presentation where they have the red zone monitoring. So that will be interesting if you want to see a partner talk about their experience with Edge Datastore, how it was a good fit for their scenario. Okay, that's me, how to get a hold of me. We have 7 minutes and 5 seconds for questions. So please ask questions. If not, I'll hang around afterwards. We can go out in the hall and have a more private conversation. So thanks for your attention. Happy to have a few questions.
Abbas al-Bashir from Saudi Aramco. You mentioned somewhere that there is a component that helps in tag naming, adhering to local tag naming conventions. So does that need any new component, something like Pi connector, replacing Pi interface to Pi connector?
Okay, so yeah, the question is if you couldn't hear it. So I talked about in context of Pi connectors, there's a new feature that we're adding to connectors that allows you to control the tag name. So again, like with Pi interfaces, you build your Pi tag, you call it the Pi tag what you want to call it, and you tell the interface to populate data into that Pi tag. Connectors, we automatically generated the tag. It was just effectively a GUID that we created based on some syntax that internally we agreed is the right thing. So what we've done with Pi connectors, or are doing, I should say, it's in development, is giving you the ability to say, no, you tell us what the tag name is that you want us the connector, to call the Pi tag. And so that requires, well, again, without getting into too much detail, that requires our most current architecture on the connectors, which internally we call Generation 2. Generation 2 is the connectors that use the Pi connector relay, that use another software application called Data Collection Manager. So it's via the Data Collection Manager, which is really the configuration interface for connectors, is where you define the names of those tags you want to create. So we took that lesson learned as we built the Edge Datastore. It inherently has that capability. It says, tell us what Modbus device you want to talk to or what UA server you want to talk to. And if you want to also tell us the names of those tags you want us to build, tell us that at configuration time. So Edge Datastore is built with that capability as well. If you don't care what Pi tag names you build, then you just say, no, just send it. The Edge Datastore will create those tags for you. But
We built similar components locally.
okay, yeah. So yeah, comment was we built a similar thing locally. Yeah, so that's we've taken that problem away from you with this new connector development about you just tell us what they need to be. You don't have to develop that. Okay, questions? That was a pretty easy one. Someone's got a harder one out there, I bet. Way in the back. Allison's going to get a workout. Now someone up front ask. This guy here can ask a question.
Hi, Carl Gerard, Show UK. Your example of the Edge Datastore on the Raspberry Pi, sorry, maybe I missed a point slightly, but that's your connector. What if I already have instrumentation on the Raspberry Pi? Like a Raspberry Pi does Dallas one wire, for example, for temperature. Can I use the same one, or do I need two Raspberry Pis?
Yeah, good question. So Edge Datastore runs on a Raspberry Pi, and that's been a very popular hardware platform for these early adopters. You know, some folks say Raspberry Pi is good for me because it's low cost. If it breaks, I just replace it with another one. Others say, no, I'll eventually use a hardened, rugged, industrialized gateway. But Raspberry Pi, it's, again, kind of our medium class. It's a quad-core CPU, at least on the Pi 3. There's a Pi 4 out that's a little bit better, and then a Raspberry Pi has a gig of RAM. So there's room on a Raspberry Pi for applications. Edge Datastore doesn't need that much resources. This is a single-core CPU with a half a gig of RAM. Edge Datastore runs fine on this. So you imagine you step up from this to like a Raspberry Pi where you've got twice the RAM and a quad 4-core CPU. You would have room for if you wanted an application on that. Or your devices could be separate. But yeah, Raspberry Pi has enough overhead to run other things on it besides just an Edge Datastore. 2 minutes, 45 seconds. More questions? All right, well, if no more questions, thanks for your attention. Again, I'll hang around here for a couple minutes or we can step outside if you want to ask me anything specific. So yeah, thanks for your attention, and again, have a great week. Oops.